Okay, so for this question, we're told that at 1 p.m., ship A leaves port P. It sails in the direction 30 degrees east of north at 12 kilometers per hour. At the same time, ship B is 100 kilometers due east of P and is sailing at 8 kilometers per hour towards P. So I'm going to draw a diagram of this entire situation so I can better understand it. So if this is due north, and this is P, it's sailing at 30 degrees north, 30 degrees east of north. So this right here we can say is ship A, which is moving at, it's 12t. The distance is 12t, because after every hour, it will be 12 kilometers further towards A. And this over here, which we were told is 100 kilometers, can we say that this is ship B. And it's moving at 8 km per hour towards P. Now, question A asks us to show the distance is given as this square root of 304t squared minus 2,800t plus 10,000 km. So this distance over here, we can represent as d for now. And we have to first find a way to represent PB in terms of a side length. Sorry, let me just label this 30 degrees. So PB is basically, so at first it's 100 km, but after every hour it's going to be 8 km less because it's moving 8 km closer to P. So it's going to be represented as 100 minus 8t, where t is the hours, obviously. And now over here we can actually use cosine rule, because if this is due north, then the angle between NPB is 90 degrees. NPA we know is 30 degrees, so that means APB is 60 degrees. And here we have all the information we need to do the cosine rule. So d squared is equal to 12t squared plus 100 minus 8t squared minus 2 times 12t times 100 minus 8t times the cosine of 60, which is equal to 144t squared plus 10,000 plus 64t squared minus 8 times 100 is 800 times 2 is minus 1,600 t minus, and then 12 t times 2 is 24 t, and then cosine of 60 is half. Half of 100 minus 8t is 50 minus 4t. So this is what we have to simplify down. So d squared is equal to this. So d squared is equal to 144t squared plus 10,000 plus 64t squared minus 1,600t minus 24 times 50 is 1,200. So 1,200t. And then 24 times 4 is, so 96. So plus 96t squared. And now let's group like terms. So d squared is equal to, so 144 plus 64 plus 96 is equal to 304. So we got 304t squared. Then minus 1,600 minus 1,200 is negative 2,800. So negative 2,800t. And then plus 10,000. And if we square root everything, we get d, or as it wants us to represent it as, d of t is equal to square root of 304t squared minus 2,800t plus 10,000 as required. So that's part A done. Let's move on to part B. So we're asked to find the minimum value of d squared for all of t is greater than 0. So we know that d squared is equal to 304t squared minus 2,800t plus 10,000. So the minimum value would mean we would have to differentiate. So d squared over dt is equal to, so 304 times 2 is 608t minus 2,800, and the constant goes away. To find the minimum value, we have to equate to 0. So that means 608t is equal to 2,800. So t is equal to 2,800 over 608, which is equal to, just putting it into my calculator, which is, so we need to find the minimum value, which is approximately equal to 4.61. All right, now on to part C. At what time to the nearest minute are the ships closest? So at this point, we've shown that the minimum value is 4.61, which means that 4.61 hours after 1 p.m., the ships are at its closest distance together because it's a minimum value. So what we're going to do is express 4.61 in terms of hours and minutes. So clearly it is 4.61 is equal to 4 hours. And then in terms of minutes, well, if we do 61 over 100 times 60, we get 4 hours, 37 minutes approximately. So this here it is kind of rounding because obviously we have to express 2,800 over 608 more accurately. But if we use 4.61, it is 40 hours and 37 minutes afterwards. So now we need to look at the time. Oops. So the time would be 1 p.m. plus 4 hours, 37 minutes, which would be 5:37 p.m. That's our final answer.